Okay, let's get started. So I have one announcement really, which is I posted the writing assignment, which is due in almost 2 months. So you don't have to start working on it right now, but maybe start thinking about it. And it should be a lot of work, but it should be fun because you're learning stuff that we're not going to get to in this class and see what people are actually using C++ for, which is pretty cool. Are there any questions? What's on Wednesday? Midterm, okay. Any questions? Who still hasn't looked at the midterm 1 sample? No one's courageous enough to raise their hand. But yeah, are there any questions about that or anything else? If there are no questions, yeah. It's still what?
The last lesson, the section.
I don't know what you're asking.
Like, you'll be testing for looking decisions.
Yeah, so what material does midterm 1 cover? Not everything, but everything up until what? Yeah, so through loops, yeah. So no functions. You can use functions if you want on the midterm, but they are not required at all. And in fact, I don't even know there's an example that could even help you. So yeah, through loops. Other questions? I think there's one over here. Yeah.
On the syllabus, it said that your final will replace your lowest midterm grade, right?
Yes.
Okay.
Well, it won't just replace your lowest midterm. It will replace any midterm for which it has a higher percentage. So if a final has a better percentage than midterm 1, it replaces that. If it replaces if it's higher than midterm 2, it replaces that too. So it always rounds it up to the highest percentage if it can.
And it's the lowest out of your midterm scores?
No, it replaces both of them independently.
Oh, okay.
So if you get a 90 on the final, on the final, and you get like 60, 70 on both midterms, it replaces both.
Oh.
Yeah, because my motivation is if you learned and can show that you learned on the final, then you shouldn't be penalized for not knowing the material earlier because it's cumulative. Any other questions? Okay, so last time we were talking about what? Overall functions, yeah. So mainly we were talking about these functions, which basically are just breaking a program down into easier to manage pieces and then relating the pieces as we need to. So that we talked about various parts of functions such as, well, obviously the name of the function, any parameters to the function, the return type of the function, and so those three correspond to the function header. And if we want to include the body of the function as well, then we form a complete function. So, and the body is the code inside the function. So the highlighted part right here, that's the body of the function. Return type is the first thing. The second thing is the name of the function. And then inside the parentheses, we have the parameters. Are there any parameters to this particular function? No. So, so you can have functions with 0 parameters, or you can have as many parameters as you want. Oh, by the way, if we did have parameters, like say we had 2 parameters, how do you separate them? Comma. Good. Okay, so we talked about how to call functions, whatnot. And then we talked about prototypes. So what did prototypes solve? What was the problem that we had that prototypes helped us solve? Not syntax.
Order of operations or
Order of something. What if we had one function that called some other function, and then that other function called the first one? So no matter how I lay those out, what's going to happen if we didn't have prototypes? We're going to have a compiler error, right? Because the compiler says we're going to look up wherever we are in a function. If we're making a function call, we look up to see if we ever can find the function. If we can't, then it just says, I don't know what this function is. I'm just going to throw an error. So prototypes helped us solve this because you put the prototypes at the top to say the function's defined somewhere, but not right here. And so what the compiler does, if you remember, it does a two-way pass over the file. It looks down and says, okay, here are the prototypes. I'm going to look for where the definitions actually are. So, but it first scans through all the prototypes, and then it makes a second pass and says, okay, I know what the prototypes are. I'm going to look for them now. So then it goes down the second time through the file and says, okay, if this one's defined here, I'm going to have the prototype say, if it's defined on line 10, for example, the prototype's going to say, oh, the real definition's on line 10. So if you're looking for this function, look on line 10. And then it keeps scanning through and it says, oh, this other prototype is defined here. So it's a way of avoiding this issue of functions calling other functions and not being able to put an order on them so that everything works. Are we required to always use prototypes, or can we avoid them sometimes? Well, we can avoid them sometimes, but if you ever have that situation where one calls another and the other one calls the first one, you can't avoid prototypes with a single file. There are other ways to get around that, but with a single file you can't. Then we talked about passing data to functions. So the square root function, as an example, takes a double as its single parameter. So we can either feed a double value like 5.0 or whatever directly to it, or we can feed in any expression at all that evaluates to a double. So could I put inside here a function call that returns a double? Yeah, so as long as I have something in there that evaluates to a double at all, we're all set. Let's just say for whatever reason, the square root function takes a string. Could I put a function call in there that returns a string? Yeah, so as long as it evaluates to the right thing, it doesn't matter. So remember, the order of operations says we do the stuff in parentheses first. So it evaluates the expression first and then returns the value. So in this case, it calculates what a times a plus b times b is, figures out, okay, that's 42, for example. And then it returns 42 to pass into the square root function. So it calculates it, sends it into the square root function. Square root function does its thing, and then square root returns with, I don't know what the square root is, and then it returns that value to C, to assign to C. So those were arguments or parameters that we saw last time. We saw different types of prototypes. Function calls can have any number of arguments. And I think this was the last slide we looked at last time. So if we want to make a function call, the arguments are in the same order. So if we call this function display data with height and weight, and so height is going to be, the value of height is going to be transferred to this h variable inside the display data function. And then weight is going to be transferred to the w variable in this function. Question for you. Are height and h the same location in memory, or are they different locations in memory? They're different locations in memory. We're going to resolve that issue today. But for now, they are different locations in memory. So note here, do I have to have this variable in the display data function, this h, have the same name as the height over here? No, because they're independent variables, but we can rename things as we want to. So it doesn't matter the name of the thing if it's in a different scope. So the h here is in a different scope than the height is here. So we can rename it anything we want. Okay, any questions before we get to other stuff? Okay, so we saw this return thing. So what does return do in the general case? So we're in a function, we see a return statement, what do we do? It ends execution of the function. So whatever it's doing inside the function, when you hit the return statement, everything is done in the function. You're done executing, and you return to wherever you were before you started running that function. So let's see if we have an example. So let's just say that this display data function was in main somewhere. So then we call display data, and let's just say after this first line, or maybe even the second line, we put a return statement in there. Then we return to the same place that we were before. So if we had a return somewhere in here, we would immediately stop and then come back to this exact same place from wherever it was called, main function, wherever it was. So that's what the return statement is for. If you don't have one, then the only way you can get out of the function then is if you go to the last curly brace of the function. So remember, for the main function, are we required to have that return 0 somewhere for the main function? No. Well, what happens if we didn't have a return 0? It just goes until it reaches the bottom of the main function, right? So, but if we wanted to get out of main early, we could say return 0 before. Yeah, so the way you get out of it without a return is if you get to the last curly brace. The value here, the thing in the expression, could be the same thing as if you passed it to a function. It doesn't have to be a specific value. It could be a variable or a whole expression or a different function call. It can be anything that you want, as long as you are returning the same type as what the function says it's returning. So let's do an example of this. Let's go back. Okay, we don't have an example. All right, so let's make up an example then. I think I had this earlier. Yeah. So, yeah. So here, so this is the example we did last time. So we were calculating the volume of a sphere. So let's just look at the cube value function, for example. What type is value? Double. So, but the return type is also what? Double. So if I return a double from this function, am I okay? Sweet. So what is value times value times value? A double, because double times double times double is also a double. It's not a sextuple or something. That's math humor for you. What about this function up here? So if we had a volume of sphere function, radius is also a double, and we need to return a double. Well, what is 4.0 divided by 3 evaluate to? Double. This one I'm pretty sure is a double as well. And by assumption, what does cube value return? A double. Because it says it returns a double. So for the same reason, we are returning a double here. So as long as I can return something that is a double or something that can be converted to a double, we're all set. It's better if you return the exact same thing, but as long as it can be converted to the right value, right type, we're all set. If I ignored that parameter, oops, and I just said return my favorite number, 42, would this be okay? What type is 42? Int. What am I supposed to return? Is this okay? Exactly. So as long as it can be converted into a double, we're okay. Ints, from what we've seen before, can be converted to doubles. Is the other way necessarily true? Yeah, as long as you don't mind truncation. But so you have to be a little bit careful here. If I wanted to be absolutely sure that I'm writing a double, I can say 42.0 or something. But as long as I try to return the same type, we're all set. Okay. Yeah, so the expression that you return can be either a single value, a variable, function call, anything that returns the same type as the return type of the function. Yeah. So the return statement can be used to return a value from the function. So in the volume of sphere function, we're returning the volume of the corresponding sphere if we passed in a certain radius. So if we passed 5.0 as the radius, it'll return the volume of a sphere corresponding to a radius of 5.0. Yeah, so here's an interesting one. So it says the prototype and function header must indicate the data type of return value. So here, all that really means is that the prototype up here must correspond exactly to the definition below. The definition below. So here in the declaration, the prototype, I'm saying that it takes a double as its parameter. There's only one parameter, and it returns a double. So when I define it later with the actual code for it, it must have the exact same type. If I change this to be int, I'll actually, hopefully, even though it probably might not, I should get a compile error. And in fact, I do. So it's a little cryptic, but you can actually see it's looking for some symbol, which is you can think of as a function. This symbol is undefined. It's looking for volume of sphere double, which is the one that's declared up here, but it can't find it anywhere. Why? Yeah, because the only possible declaration has an int as its parameter, and those aren't the same. So as long as the prototype and the actual definition are the same, everything's good. So as long as they're the same, we're all set. Of course, the name of the function has to be the same, and the return type also has to be the same. All three parts have to be the same.
Why in the slide does it say not void? Do you not need to show void or?
Yeah, so that's a good question. So you may be looking at this and say, okay, not void, why is that there? So it says, it's kind of hard to read it from here, but it's the return value here. So what does void correspond to? It doesn't require a return value. Can I put a return statement in there, even though it doesn't return anything? Yeah, so what you do in that case is you don't say return expression, you say return semicolon, and that's it. So the return here just means stop executing the function, you're not returning anything. So when it says return value here, it actually means returning a value. So void functions don't do that, so that's why it says not void. But I could put a return statement in a void function, it just doesn't return anything. Okay, yeah, so the calling function, so if I'm calling volume of sphere, usually it should use that value. So if I'm calling a function, I'm expecting to get a value back if it's not a void function. So if I'm calling this volume of sphere function, I should either be assigning it to a variable, printing it, or doing something useful to it. Because if I'm not calling it, why is the function actually there? Because I'm not using it. But as long as I'm using it, that's best practice. Sometimes you don't. Sometimes you don't. You just throw away the return value, but the vast majority of the time you actually use it. Okay, yeah, so here's an example. Suppose we had a function which its sole purpose is to figure out whether user's input is valid. So if user's input is good. So it returns a bool, in this case. It says, I pass in the integer parameter called val, and its job here is to say it returns true if the value is good and returns false if it's bad. So if the value is at least the min and at most the max, then it's inside the bounds and we're all set. So we should return true. Otherwise, we return false. So this if statement right here we can think of as putting in either a different function or probably the main function. So then we say, we call this function and then use it in our code. So isValid returns what type? What does isValid return? A bool. So are if statements good with bool values? Yeah, because an if statement, whatever is inside the condition has to evaluate to a bool value. So if I pass in a bool, we're all good. So we call the isValid function with, we can think of score as maybe some user input. If isValid of whatever the user's input is, if that evaluates it true, then the code corresponding to that if statement could be, now we can work with the user's input being valid. if this condition evaluates to false, we know that the user's input was not good. So we before, when we were doing user input validation, we were actually doing the condition ourselves. So if we were doing the condition ourselves, we would do instead something like this. So we would have, instead of val, we would have score. So we would just forget these functions up here and just say if score is at least the min and score is at least the max. That's what we were doing before. But now we were offloading that work to a function because that's a single task. Let that function do what it's designed to do. Not muddle all of our work inside the main function just doing user input validation. Let the function do all the work for us and then just let us handle that result. Okay, so let the function do the dirty work for us. Yeah, so let's just say that we were looking at this function. So the header, remember, is the first three pieces: the return type, the name of the function, and the parameters. How many parameters for this function? 1. So there's only 1 parameter for this one. So sometimes what you might do is, if you look at the previous slide, we had two different return statements, one inside this if statement and one in the else block. So sometimes what you might do is you create a bool variable, assign it inside the if statement accordingly, and then return all the way at the very end. So it's a matter of style. They're exactly the same, they do the same thing, but sometimes you might want to do one versus the other. I personally prefer this one because you're not having to look and see, okay, I'm managing this bool variable, now I got to look all the way down at the end of the function to see what I'm actually returning. Here, the return statement's right there, and I don't need to think about it anywhere else. But here, sometimes this one's necessary, but for what we're going to see, that they really are the same. Okay, any questions on what returned? Yeah.
So on the previous slide, so that if statement that was there originally, if the return was false, would that?
Yeah, I need to fix that. Yeah. Mm-hmm.
Okay. So if the return ended up being false, would that if statement even run at all?
The code corresponding to the if statement, no. Because the code corresponding to the if statement can only be executed if it's true.
Okay, cool.
So yeah, so you're offloading the work essentially. Other questions on return? Okay, let's see. So functions can be used for all sorts of purposes, and in assignment 4 might be a good idea to use functions, but definitely in assignment 5 we're going to be using functions. But one of the main purposes of functions, as we have seen, is to offload work. So we want a function to do exactly one task, maybe to do some computation or something. One of the common approaches is to put a menu, like presenting a menu inside of a function. So instead of putting the entire menu's cout statements inside the main function and making the main function really long, we can just say print menu, and then the print menu function will just print the contents of the menu. So if we have a function called print menu, what do you think should be the return type of that function? Well, it depends now. So the function name should tell you a lot. It says print menu. Does it say create menu? No. So what should the body of the function look like? Just a bunch of what statements? Cout statements. Do I need to return a value? No. So what should the return type be? Void. But if I instead was creating the menu, what type should that be that was returned? A string. Because I'm creating the string corresponding to the menu, and then maybe we'll do some work with it to whoever called the create menu function. But now all I'm doing is just printing the menu. How many parameters should go to that function? Now it might depend, but a lot of the time, if you're just printing stuff, you probably aren't passing anything to the function. If you're just printing a menu, it's just static, like the in and out menu. Does the menu change depending on who visits the restaurant? No, so it might make sense to have 0 parameters for that function. But maybe we're presenting a form to the user, and we want the form to adapt to maybe if the person's a student or a faculty member or whatever. So then we actually have to say, is the person that's being passed a student, faculty member, a professor, or whatever? So then we might need several parameters for that. But if we're just printing static content, all we need we don't need any parameters for that. So function design is actually very important. But so menus are typically offloaded to a function for it to do the dirty work for us. Okay, any questions on that? Okay, so now I must warn you, the next 2 slides, and I'm not kidding, are probably the most important slides of the entire class. I'm not kidding. So pay special attention because we are going to reference these 2 slides a lot, pretty much the rest of the class. Ready? Okay, so what was the issue that we were seeing with functions in terms of like modifying the original value in the main function? So let's just say we were calling a function and we passed a parameter over. What do we know about the locations in memory of the value? Are they 2 separate locations or are they the same location? Separate locations. So that behavior of when you have 2 separate locations, that is called pass by value. Okay? So pass by value means I'm passing the value into this function and it's copying the value to wherever the function is. So if we were looking at the function is valid, maybe let's look at this example instead. So look at the score variable here. So let's just say it's an integer that the user inputted. Maybe they entered 42, random number I picked. So they entered 42. The val variable over here, that is a separate location in memory. So if you just took a picture of the memory contents of your program right after we called the isValid function, you should see 2 instances of 42 because there's one still from the main function that the user entered, and then there's a copied version over in the isValid function. Okay? So this shouldn't be too hard to understand, but are there any questions about pass by value? So pass by value, all it is you're passing the value in and it's copied over to another place. Typically when you are working with functions and you're passing via the parameter, the value, to the function. So the key for pass by value is you can't access the original value. So if I modify the 42 inside of the isValid function or whatever function, it's not modifying the original one. Okay? So that's the key of pass by value. So when would you want to use pass by value? Yeah, if you want to keep the original value intact. So maybe like if you were building a form for a user to input data to. So maybe we could have some function to say, I'm going to check whether the user's input was actually valid first. Do you want to accidentally mess up the user's input of the form? I see this all the time on forms where I accidentally put in a wrong value, click submit, and then it erases everything from the form that I already entered, even though there was one thing that was wrong. I don't want to mess up the user's input so that I don't have to re-input every single thing in the form. So that would be a good case for pass by value. Okay? Yeah, so changes made to the parameter in the function do not affect the value in the from where you called it before. So the score variable from before is not affected if I change it inside the function. I'm reiterating this all the time because we're going to see it all the time. But are there any questions about pass by value?
So you could use both versions of the value.
I don't know what you mean, both versions.
Well, so you can use the original value that was inputted, and then you can also use the function version of the value.
Yeah, so I can use them in the sense that when I call the function, I only really have access to that particular copy, not the original. But when this function's done, I return back to here, and then I can use the original one. And by the way, when the function is done executing, this version of that variable is deleted, is done. Because the function is done executing, it doesn't need it anymore. But now I can access that one, yeah.
What if you just return the new value from the function that received the
Mhm.
parameter,
Mhm.
return the value if you wanted to change it, and send it to the
And assign it to the original one? Yeah, so you could do that. So if we look at this code right here, so I could say, well, this radius over here, this volume of sphere version, is not the same as this radius over here. But maybe for whatever reason, I could set radius to be equal to that. So I could do this. But now that puts burden on the person who's using that function, who's calling this volume of sphere function. So that if they want to modify the original one from the volume of sphere function, now they have to assign it to their variable. So instead of having them just rely on the function to do that for them, if they want to modify the original. So pass by value is just a safeguard in some sense of not modifying the original. Any other questions about pass by value? So if we do want to modify the original, then we do something different, something called pass by reference. Okay? So I'm probably going to say the word reference about 10 gajillion times, that's a scientific term, throughout the rest of the class because references are really important. So if we are going to pass by reference, and we'll see an example, then if we make a change over here, it modifies the original. So instead of having two independent copies, if we do this referencing thing, then they really are the exact same location in memory. Okay? Even though we're in a different function, we're still accessing the exact same place in memory. Okay? So if we changed our volume of sphere function and we passed the radius by reference instead and modified the reference for whatever reason inside of that function, it'll modify the original one. Okay? So this is actually a good idea a lot of the time, and we'll see an example of, in fact, assignment 2 solution where this is actually really useful. So it provides a way for the function to return more than one value. I don't really like this, but because like if you're modifying the original and returning something else, now the user has to think, okay, what is being returned here? What variables are going to be potentially modified? You got to think about that sort of thing. So I don't really like that, even though it's technically true. Yeah, so it allows the function to modify the values from wherever it was called. So if I had a radius over here, and I call the function that passed by reference, it modifies the original if I changed it. So how do you actually do this? The way you do it is really, really simple. So you go to the function parameters and put an ampersand in. So notice here, so if we just had a normal function, we would just have int, comma, int. So that would be a pass by reference scenario. If we put the ampersand right here, that says we're passing by reference. Okay? So if we did this in the volume of sphere function, all we need to do is say reference, and since the prototype has to match exactly, I put an ampersand there too. If I wanted to do it with cube value also, I put a reference, I slap a reference on, and that's all I do. And so now we're passing by reference. What's another reason we may want to use pass by reference? Of course, we could modify the original value, but why else might we actually use it? Suppose we were reading a 10 gigabyte file into a string, and then we were going to pass by value that string to a function, maybe to process it. What's going to happen? It's going to make a copy. Do you want to copy 10 gigabytes of data? No. But so then we say put a reference on. But do I want to modify that data accidentally? No. So we're stuck in a conundrum, right? We want to not copy the data so that we can save memory, but on the other hand, we don't want to modify the original. Anyone have an idea of how to fix that? It might actually, I actually don't know. But what's a way that we can say, we have a variable and we don't want to change its value? We can put the keyword const. So what happens a lot of the time is we put const on front of the type that we're working with. So if we want to not have to copy the value, but we don't want to change it, we put const, what is called const reference. So in this case, we're doing a const reference of a double. So we have this double in location. Can this radius over back in main be changed? Can I change radius in the main function? Yes. Is it declared const? No. Can I change? So is this radius right here referring to the same radius? Yes. Why? Because it's a reference. The const only tells you you can't modify it in this scope. So when I put the const right here, inside this function, I can't change the radius. Okay? So I can't change the radius here, even though it's the exact same location in memory. So this actually really solves the problem for us. We don't want to have to make a copy, but we don't want to modify it accidentally either. But any questions on just making a reference? Yeah.
So if they didn't have a const in front of it, and you were to call it in like a later function, and it modifies it back in the function itself.
Yeah, so like I can do something like this.
Yeah. And would it then compound like into the rest of the program?
A good question. So what would actually happen here? So let's just say we let's just figure out what it is. So let's like see out the radius just to see that the value definitely has not changed. And then let's call volume of sphere with the radius, maybe with a new line. And then let's see out the radius again, because we know for sure that the value of radius does not change anywhere in any function, correct? All right, so let's actually compile and enter our favorite radius. What do you see? We see out the radius right here. We print the volume of it. Oh, the radius changed. So it in fact modifies the original here. So this radius did change. So that actually tells you that this ampersand, this reference, really does reference the original variable. Okay? Any questions on that? Yeah.
More of like an observation. Like I'm trying to understand this. It's like the difference between like a desktop shortcut and like copying the contents of a folder to the desktop.
Yeah.
Kind of what we're looking at.
That's exactly a good analogy. So the analogy that was made is if you make a copy of a folder with contents inside of it, are those contents the same place on your hard drive? No. But what if you make a shortcut instead? An alias in some context. Yeah, it references the exact same location in memory. Even though it's over here, the location of the alias is over here, it references the original place on the hard drive. It's the exact same thing here. Okay, any questions on references? We'll see more of this, though. Yeah, so the only thing that you need to do for a function, if you need a reference, just stick an ampersand on the variable. Oh, by the way, could I have one parameter be a reference and one be a value? Yeah, you should be able to, and in fact you can. So sometimes it makes sense to have one thing be a reference and one thing not be. So like if you're passing a string, for example, pretty much always you put a reference on it, because if you have a load of data in there, you don't want to make a copy. But for like integers, if you are going to not want to make a copy, the size of the reference itself is the same as the size of the integer anyway. So if you figured out, okay, the integer is 4 bytes, the reference is in fact also 4 bytes. So you're not really gaining anything by putting a reference on an integer, unless you want to modify the original. So in some contexts, it makes sense to have it be a reference variable, and sometimes it doesn't. But it really depends on the scenario that you're working with. Okay, so looking at an example, another example. So let's just say these 2 lines at the bottom are in the main function, or it doesn't really matter where. So we have a local variable that's set to 5. We call the square it function with the local variable. We see, okay, the square it function, is this a reference? Yeah, how can you tell? It has an ampersand on it. So we see, okay, num times equals num. What do you think that does? Yeah, so effectively, it's num is set equal to num times num. So in fact, what it's doing is it's squaring itself. So if you entered 5, it would become 25. If you entered 1, it'd become 1. If it was 10, it'd become 100, etc. So we see that it was 5 here. Because it's a reference, am I, in this statement right here, modifying the original? Yeah, because it's a reference. What if I took away the reference and just left it like this? What would the local variable after this function call now have? 5. Because we're not modifying the original. Because it's not a reference. But because we had a reference here, now it modifies the original. And so it becomes 25.
You could essentially perform the same task by returning the value 25 at the end of the function.
Yeah, so the point that was made is you could return this and assign to the local variable, but now you have to actually have to do that in the main function. So in some contexts it makes sense to do that, some contexts it doesn't. Like in this case, yeah, I would actually just return the value and then set it, because if you look at this function name, it's square it. So you can think of that as being you're taking something in, finding the square of it, and returning it. But in some contexts, it may make sense to modify the original here. Yeah.
Is that why when you were doing that example for us, when you first showed us passing parameters, the menu, the double doubles and stuff, is that why you were trying to change the double double variable?
That's exactly it. So let's actually look at that briefly. So let's, I deleted it, so I have to copy it over. So if we look at the assignment 2 solutions here, you notice, okay, well, all of this stuff is almost the same, right? So there's a lot that is the same. The only thing that's changing here is this text right here, as well as which variable that is going to be modified. So let's actually make a function. Well, let's try to design the function first before we actually do it. Well, what should I pass to handle this difference? Like the double doubles cheeseburger part. A string. So should I pass that by value or by reference? I could do value. Does reference matter here? Not really, because do I care that if I'm going to change this at some point? No. So if I'm going to be passing in double doubles and then the next time I'm going to pass cheeseburgers as a string literal, then I'm not going to be modifying the value anyway. So I might as well just pass by value. And the strings are short enough that I'm not really worried about using too much memory. But for the variables, do I want to modify the original variable in this case? Yes, because the variable's in the main function, and I don't want to have to calculate the number of each item, return it, and then set it to the corresponding variable. So I want to modify the original. But do I need to return anything if that's the case? No, because I'm not setting the original variable anymore. Do I need to return anything? No. So if I'm not returning anything, what should the return type be? It should be void, because I'm not returning anything. So let's see. Let's make a void function then called handle item. And then it takes two parameters, one of which is a string and the other one is an int. An int value or reference? Reference. So let's just say we have the string item name, that's the name of the string, the text, and then have an int reference be the num of each item. I'm going to call it num item. So what we're going to do is we're going to copy this, or cut it really, and then put this in here. I see the return 0 in there. I'm going to address that. So what should go right here instead of double doubles? Item name. So I'm going to close the quote off, put item name in, and then because I want to reference the actual variable, not the string item name. What should go here and here? The num item. What's going to actually happen here? So ignore the return 0. I'm going to cin here. Does cin modify the original value? Yeah, because cin modifies the value of the variable you're working with. In fact, the cin operator right here, the double greater than, takes the argument by reference. So that's how it's able to modify the original value even though there's no equal sign here. So this will modify the original value, which is great. What happens here? Well, the return 0 actually is in conflict with the void function. Why? Because we're returning a value. But even setting that aside, what if I just put a return statement right here? What would actually happen? It would go back to the place it left off in main. What did return 0 do before I did this modification? It exited the main function entirely, stopped the program. So here I want to do something that exits the program from this function, right? Return's not going to get that for me. It's going to return back to the main function and continue executing from there. Now, you could just say, well, I'm going to do that and say, let's just call this function handle item double doubles and then DD burger here. And then I could say, well, if DD burger is less than 0, then return 0 here. I could do that if I wanted to. Does this look like fun? No, because now I need to do this exact same 3 line, okay, very similar lines of code for each of the items on the menu. Let the function do the work for us. But we don't know how to stop the program that way. So, if you are curious, you should look at the very last 2 slides of this set of slides. So there's actually a function called exit, which exits the program, stops execution of everything from anywhere. So I would encourage you to look at that. But remember, pass by value means we have 2 different locations in memory. Pass by reference means same location, you can modify the original, unless you put const on. Okay, any questions? Great, I'll see you Wednesday.